Hello everyone. So we will keep going with our problems, and this problem here is it's about fluids, right? And as you can see, we have a device that's gonna measure a pressure inside a box. For example, you can see here that we have the question is, what is the gas pressure inside this box here? And as you notice, we have a tube, a pipe, right? And we have mercury inside. Okay? So, first of all, we need to remember two important things. The the density of mercury. So we have density of mercury. Ag is the what we see as mercury in a periodic table, and it's going to be 13,600 kilograms per cubic meter. Okay, and we we can see that we are dealing with with this mercury here, and up here this it is open, right? And because it's open, um, we can consider the out pressure, I mean the pressure that is measured here in this point, as uh, the surface pressure, right? I mean sea level pressure. So it's going to be 1 atm. So 1 atm, 1 atm, a 1 atm, sorry, 1 atm is equals to 101.3 times 10 3 Pascal. Okay, so we can, because we need in Pascal, right? If you remember, pressure, it's equal to force over area, and this is going to be equals to newtons over square meter, and this means this is equals to 1 Pascal. Here, okay, 1 Pascal. Okay, so we have these two numbers here. So why we are dealing with all these new numbers? Okay, because we need to measure what is the pressure inside this box. Well, how can we do that? We have, if you remember, we have two formulas when we are dealing with pressure, and we can calculate the pressure, right? And both will take into account the exterior pressure, that means the pressure that is linked to outside of the system, and the density of the liquid that we are measuring, okay, gravity, or the n times the height. Well, this first one here, equation 1, generally is when we are dealing with depth, right? For example, if we need to measure, if we are in the surface in a river, and we want to measure what is the pressure 10 meters down inside the river. Okay, so we can use this guy here. First of all, because we know that the pressure that's going to be measured inside the river, that 10 meters inside the river, uh, it will be higher than the outside pressure. Okay, so this is why we have this plus sign here, because we need to add the external pressure, atm, 1 atm, plus the pressure due to the depth. Okay, now this second question, I mean the second equation here, it's when we are going up. For example, when the airplane will take off, okay, so the pressure that he start to suffer on when it goes up, it will be decreasing, because, as you know, we're going to be less air upstairs. I mean up, right? So this is why we're going to have the initial pressure minus the altitude, I mean the height that we're going to go up. So this one here, we know by the drawing, because of the drawing, that the the pressure inside this box, it will be less than outside, because first of all, the mercury, it's going in this direction, so it's trying to flow to this direction here. That means the pressure here inside, it's less than the pressure outside. So let's use this equation here. So what we're going to do, we're going to be, the pressure equals to initial pressure minus the density of mercury, right? Mercury's density times the gravity times the height. Okay, so let's put the numbers here, right? So the pressure will be, what is our initial pressure? Let's do this guy because it was the one that that was exposed to, right? So it's going to be 101.3 times 10, 3 Pascal. So now I'm going to be minus, what is the density? What is the mercury's density? This is going to be 13,600 kilograms per cubic meter. Okay? And then times 9.8 meters per second squared. This is gravity. Now the height. Well, the height, guys, we can do a balance here because look, we have this height here, 16 centimeters, and we have this another one here, 6 centimeters. So think about like the way that the liquid flows here. Look, they will go this way, right? So that means everything was balanced before. So this difference here between this point and this point will be our height. So what we can do is going to be 0.16 meters, because remember we need to change everything from centimeters to meters, minus 6.0. Oh, I'm sorry. You see, I told you to do that and I didn't. So 6 meters, 0.06 meters. Okay, so now let me get my super calculator here and to do all this calculations. So what we're going to have, we're going to be 13,600 times 9.8 times 0.1. So this will be this guy here. Let me go here. Let this guy here will give me 13,328, and this guy will be, we can consider Pascal, right? And so we're gonna do 1.1 300, right? Because it's gonna be times 3 here, minus 13,328, and it's gonna be 87,972 Pascal. That means I can consider this one here as 88, for example, kilopascal. If you remember, 1 kilo means 10 to 3. Okay? So with that, you can see that the pressure inside this box is less than the pressure outside. So this is why we have all the liquid here flowing to inside the box. Okay, I hope I helped you, and let's keep doing physics.